right, so over the summer, my boss had an idea about trying to collect data and how to incentivize people to do it. And one of the ideas was a bar robot. And at the time, I realized it was too much work and had to have stuff to do, so I didn't do it. And sometime in December, I forgot how much work it would be and agreed to do it. So I was able to convince my boss to let me do this, and been working on this for about the last 2 months. It's finally like mechanically complete. The servos work. It does dispense, but I don't have an electronics here for that. There was a lot of lessons to learn doing this. It's all from scratch. It all comes apart like down to the components that, which is nice. The prototyping stuff I used was very useful. This thing's been reconfigured like, I don't know, this is probably the 7th or 8th like reconfiguration of the beans and such to get all of this working and situated. A couple nifty hacks I found was to get a good sliding surface here. I was able to just glue wax paper with super glue down to the wood, and it makes real low coefficient of friction there. So that was a nice hack that worked. And none of my robots are complete unless they have some, trash, like somehow reused, recycled into this. So I was able to use the tops of these bottles to as like drive pulleys for the servos. So that's about it. Anything for now.
Can it serve a drink?
It can, just the electronics aren't finished yet. I need to, it's all like I've fretboard stuff that'll operate each piece of it. I just haven't integrated it all together yet.
Did you enter Robo games?
No.
There is a concept there?
Okay.
There is a bar.
Very good.
So roboticstrends.com had a drawing last spring to win this personal shopping assistant robot called a Budgie from 5 Elements Robotics. And I entered the drawing and won this personal shopping assistant robot. So I thought I'd bring it in and show it off. It's called Budgie. I don't know why. It has a couple of modes. Its main reason for being, of course, is to help you carry your stuff. So it's got this handy bin on the front with a zippered cover so you can put all your things into that basket. And if I turn him around, so he comes with this little ultrasonic beacon, and he has 2 ultrasonic microphones on his ears there. Turn this whole thing on. And when I press the button on his head, it's so the company that makes this showed it off at CES in January, and they pointed out that
Mark, hold the mic next to the sound so that we can hear the interesting beats.
so it's hold on. So it has ultrasonic sonar all around its base, and there we go.
Go home, Budgie.
Come on.
What's that, Budgie? Timmy's in a well?
So, as if this was not bad enough, I feel like I should send an apology letter to 5 Elements Robotics. So, besides this, yeah. See, now it's really confused because it's lost the transmitter. It does also come with a Bluetooth app so you can drive around manually, as well as get voice alerts from the robot as to what it's up to, status, and so on. And
Got a fish set. Say it again, Marvin.
let's try that.
I have encountered an obstacle.
You hear that? Hang on. So if
I have encountered
yeah, I know you.
I can't detect your transmitter.
Man.
Please check that it is powered on and connected.
Is that awesome?
I am now in manual mode.
Yes,
I
yes.
can't detect your transmitter.
I know you can't.
Please check that it is powered on and connected. I have encountered an obstacle.
No.
So in spite of knowing that it's encountered an obstacle, it does not stop it from necessarily running into the obstacle. It just gives you a little warning first and just goes ahead and plows into you anyway. I also thought that some of the jerkiness of its driving and falling was due to the fact that...
I have encountered an obstacle.
Thank you. I thought... That's not its default. It defaults to the American accent. I thought the British accent sounded more appropriate. I thought the whole jerkiness of the driving was due to the fact that it had no load in the basket. Whether it's in manual mode or automatically following, it does this sort of jerky stopping. If you put 15 pounds of books in the basket, it's just as jerky as it is with no books in the basket. It's no different. But anyway, it's a lot of fun to mess with, and I thought I'd bring it in while it's still in sort of stock state before I took it all apart and broke it.
Hi, my name is Aditya, and what I'm going to actually I had one more idea. I don't think we have a overhead projector in here, so yeah, it's basically related to actuation, and I'm looking for collaborators. So if you're interested, just let me know so we can work together. So the idea is one of the problems that I encountered is I was inspired by this amazing humanoid robot called HA and ECCE, and so the thing that I faced was very complicated in that is that how it's being actuated, and the guiding principles basically in essence is that they're using the conventional motors and then building an algorithm off of it, and I came to a conclusion that probably it's gonna have a very heavy back-end computing. So why not rethink the approach to actuate from first principles, and maybe we can reduce the computing the computing requirements in the backend. So we all know solenoids, they just actuate in one direction. They give you a stroke, so it can be either X, Y, or Z. And motors, they have a shaft that's running, and then anything you mount on the shaft of a motor, you can basically trace X and Y in 2D. So you can have 2D and 1D linear coordinates, but there is nothing that I know of which can actuate in 3D simultaneously. And so this design basically was inspired or with the need of, we came up with it because we want to actuate X, Y, and Z simultaneously. So what it is basically it's a ball joint, and it's a spherical ball attached to an arm, and then on the bottom you have a hemispherical sock. And as you can see, I don't know if we can zoom in, but yeah, if we zoom in enough, keep going. Okay. So,
You can go closer.
Come here.
okay. Oh, this is the camera?
Yeah.
No.
No,
No,
it's
two different cameras.
Front.
With your
Right
right
in
eye.
between the screen. Hill.
This one.
yeah.
Your right.
No, this one.
There you go.
Okay.
Stop. Don't move. There you go.
Lower. Yeah.
Okay.
So,
Don't move.
yeah. Okay. You can see the sphere inside it moving.
Yeah.
Yeah, almost feel it. Yeah. So the shiny thing in there is a powerful industrial grade magnet, and that's I call it passive reactive element. And you basically take in an active electromagnet. Active. The reason why I say active is you can control it when you power it on, what kind of voltage you can apply it, what kind of current you want to apply it. So basically, what I did was to take this conventional ball socket approach, and then if you look at the work volume, what kind of volumes we can have. One extremity is having this one, and the other is being this one, and then if you swivel it, you have inverted cones frustrum. That's the kind of work volume that you get. And by embedding a passive reactive element inside it and having discretized energy regions around the hemispherical sock, which we can control hopefully and build a firmware for it, you can have a mapping for what kind of position you want to end up with, and then you can map it and just say, energize electromagnet 1 and 2 with a certain current and certain voltage, and have a first order or second order differential of where the magnetic intensity would be, and then how the passive reactive element is going to react to that point of magnetic field. So that's the idea, and so basically, the end result of this that I would like to see is that we can replace a couple of motors, at least one or two of them in an industrial, like say body sprinting robot, or even in humanoid robots, because this is the closest that can get to a biomechanical configuration. Yeah, that's about it. And right now, so this is made up of Teflon using conventional manufacturing. So we can go for 3D printing and then have a firmware developed. That's the idea. So let me know if you're interested or excited to go ahead.
Question.
Just a quick question. You can control the XYZ position, but can you control orientation as well?
It's
That
not.
would be
I mean,
something needed
so
to-
far, no. I mean,
Okay.
one of them being, I can give you reasons why I couldn't do it, but yeah, so far, no.
Okay.
Yeah, cool. Thanks.
Thank you very much.
So this is our another prototype for the NASA sample return robot challenge. So this year we decided to try something completely different, which is use a small robot to find samples one by one. So it doesn't have any odometry or sensors, except it will have this camera rig on it. But right now, what I'm trying is so these cameras will be tracking this fiducial. So the control station will know the location and orientation of that robot, and so the rules define approximate locations of the samples. So we know that the sample is somewhere around there, within 2 meters or 5, depending on the sample. So the idea is that the base station will basically remote control the robot to the area, and then it will find the sample using the cameras. And this is the tracking part. So let's see if something works here. Okay, that's a good sign. Now, so now we need to show it the robot so it starts tracking. And right now I'm going to click in Arvis, and hopefully the robot will go there. So at home I tried to go for a meter or so. Let's see what happens here.
Put the floor robot in the lower left of the screen. So maybe you can get the tracking in the upper, the lower right, and then the tracking can be in the upper left. I was trying to yell loud enough, but that's okay. Hey, there we go.
I think that it arrived. Have some more space. I'll probably go behind this structure so to see.
Are you actually using stereo goats from the two cameras?
No, this fiducial library doesn't really need stereo.
So you got one light on.
If it's not using stereo, how does it know when it's gonna
Well,
be
well,
there?
you can tell how far from the tags if you put in the geometry, so it'll actually tell you the plane.
Yeah, so it knows how large are those markers, so it can calculate how far they are.
By the size of the marker?
Yeah.
Is that gonna be robust at 60 meters?
That we will find out. But we can always use larger computer, more resolutions, because this will be on the base platform where we can have a server. Yeah, that's it. It worked.
Is that, your stereo vision going to be at your base or on the robot?
Both. Well, we will see. We need stereo or not.
Because
Probably
I've
we
seen
will.
that on the robot.
Yeah, this
Hear
will
the
actually
demos.
go on the robots.
Yeah,
and on
yeah.
the base we will have a bigger
Oh,
rig.
okay, that's where you have your,
Okay.
yeah.
As Gertz just showed you, that's, the base station is going to get the minion close in the general direction of the object. Last month, I demonstrated how with a stereo pair you can visually get a 3D point cloud and get the distance to various objects that's in view. And today I'm going to show how to, the minion, how it's going to actually find the object once it gets close enough. This is only first order stuff because I just started this after lunch today and just got it working 10 minutes before we started. But basically I'll show you a real quick picture. Gertz provided a bunch of different pictures of the purple rock. And it's even hard to see the purple rock in some of these. I downloaded 4 of them just because it was
Here's a
difficult
purple rock.
for the purple rock.
Official color.
Here we go. I did not have this purple rock for training data for the neural network, so the only information I gave it was it's purple. And I'll show you some of the results. First, I want to show you what it ended up doing. A lot of people like to convert RGB into HSV, and as it turns out, you actually lose fidelity when you do that. In this example, basically I said it's purple, so it's like the color is going to be near this point of the RGB value. And as you train it on different rocks, it just basically builds a weirdly shaped bounded volume within the color space to find objects of that color. So started out, I just said, it's purple. So it started out thinking, okay, it's going to be exactly FF00FF. And of course, in the pictures, it isn't. Here's some of the results that we got. So here, the purple rock is actually kind of hard to see. Is there any, everybody can see it? Well, we're humans, we can see it. And when we're looking for it, we kind of found it. Now I want to zoom in on that area if I can. Where's the zoom?
Magnifying glass on the
There we go.
Keep moving.
There we go.
I think you gotta hold it.
It works easier with a mouse, which I don't have. But anyways, suffice it to say, it did find the purple rock. Some images it didn't find the purple rock too well. Like in this image,
up in the upper right-hand corner right here, there's kind of like purple shaded things in the darkness. And at first it found that. Eventually, yeah, so I can't show you a success. This was a failure picture where it could not find the purple rock. It kept finding things off in the upper right-hand corner. Here's blurry image, and you think, do you really need a blurry image? Do you need a not blurry image? Turns out that blurry images actually help you because it kind of takes all of the details and blends it into a single color. So it did find it. Now you'll notice it found the brighter part of it in the upper left portion of the rock, which is like the shiny reflective section. There was another algorithm I was experimenting with that actually finds, yeah, so there you can see the difference. One algorithm finds the shiny top, and then another one finds a more saturated color purple on the bottom.
So is this a single camera or multiple cameras?
This is a single camera. Last month when I showed you, you needed 2 cameras. It was a stereo pair. So imagine if we had a stereo pair of these. We can tell what is the distance
Of that object.
of that object, and then this algorithm is, let's find that purple rock
Okay.
once we get close enough. So here's an example. Again, this was kind of obvious. You'll notice it finds the really shiny white part, the reflective part of the rock, which is surrounded by the purple. And then the next algorithm is way down in the darker, more saturated purple area. Yeah, so I'm actually pleased that it was able to find the purple rock in some of these pictures. This one I'll work on to see why it was failing. Maybe it just needs more training data, not sure. But anyways, this is the software that's going to go onto Gert's robot to hone in on these objects. And then we'll have to train it for each object that's in the challenge.
So have you figured out how you'll train for the medium and hard objects?
I don't know the medium and hard objects. I think the hard objects, they're not going to let us see ahead of time. And I think they're shiny. It's like mirrors.
That's right. And the medium objects, they only give you a range of colors.
Yes, those will be a little bit more difficult.
Yeah, but the challenge is in 2 parts, and unless you do the first part, there's no second part.
Right.
Yeah, I think the first part is we find the white with the hook, and then we find the purple rock. And then I'll think about finding mirrors and shinier objects later. That's it.
Thank you. Okay, thank you for being so patient.
So this is a little tank robot I've been working on. I'm a hardware person, so this is kind of my first time delving into software. So I have it set up with an embedded Linux Jetson TK1 board to do all the main computational processing. And then I have an Arduino kind of slave board to do all the I/O interfacing with all my motors and all my sensors. This is how it sits right now. I have a Nerf turret that's catted up. It'll be completely automated, and there'll be sensors on the turret as well, so I can monitor what's going on with the turret. Yeah, this is kind of how it sits. I got motors hooked up like last night, so it's not too far along, but it's come together.
What do you want to do with it?
Learn software mostly. I just kind of want to get the feeling of how it ties together. I've kind of been stuck in the hardware realm, so this is kind of getting outside of that and figuring out the whole system.
Very good. Okay, is there a question?
Yeah, so you haven't thought about software yet on it?
Well, it's going to be a ROS system, I know that. Anything outside of that, I haven't really delved too deep into it.
Okay.
ROS Arduino Bridge.
Yeah, exactly. No, and I've set that up, and I've done some interfacing between them, so yeah, that's going to be pretty valuable.
So this is our table bot, and this is the second phase where we find an object and push it off of the table. Right front. So we did this before where we were trying to avoid coming off of the table by adding the sensors on each corner. So we kept that. We added this top plate here to kind of tie everything together. Mostly to provide a platform for this scanning sensor that we've added, which is used to locate the object. And this is a heavily modified parallax Arduino Bobot. So the sensor doesn't have a very long range, so it has to stop periodically, and it's also slow to scan. The servo is actually moving it mechanically.
What's the robot's name?
Robot X.
Is the sensor looking for shape or color or both?
No, it's just looking for reflection.
On its actual
It's infrared.
Oh, yeah.
And it only works about a foot.
One of those alphabet robots, huh? That's two.
Oh, 2 for 1.
End of the box. So it has 180-degree scan range, so it kind of has a blind
You can get
spot.
it there.
I think it's
You
good.
can get the pink sensor.
Gotta find it.
going now.
What's the range of that sensor?
It's about a foot, maybe a little bit more than that. They claimed in the catalog where I ordered it that it was a meter.
Nice.
All right. Thank you.
What's the logic you have for when it stops and looks around and then which direction does it move to go further? Random or?
It'll set off in a certain direction, just whichever way you point it, and then it'll go. It's actually a state machine, so it counts through several cycles of the state, and but right now it's set to 100, so it'll take 100 steps, and then it'll scan around, look for something. If it doesn't see anything, it'll continue in the same direction. Yeah. So, very good.
Okay. Are there any more robots tonight? Okay, let's give a big round of applause to all of our robot show and tell people. Thank you.